Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, crack a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guests today are the Meriçli brothers, Çetin and Tekin. Çetin is the CEO of Atlas Robotics, and Tekin is the CTO of Atlas Robotics. Guys, welcome to the pod.
Thanks for having us.
Yeah, thank you for having us.
Thanks for coming on. I've had both you guys on individually before, but this is the first time having three people ever on the podcast in the history of Collaborative with Spencer Krause, and my first time having you guys in the studio, so it's a real pleasure.
Awesome. You like to be the first.
Yeah, number one.
Always.
2 and 3.
Excellent.
Awesome. So I guess I'd be interested to hear kind of what Atlas Robotics has been up to these days. It's been a while since we last talked. I mean, you guys have been making big moves. What do you want to tell the world?
Well, I'll let the CEO actually do the opening.
All right, let me start from the bigger vision and down to what we are doing day to day these days. At Atlas Robotics, our grand vision is to redefine physical work.
Cool.
Be the ultimate physical AI provider, not just for Earth, but anything beyond. So even the sky is not a limit for the eventual very long vision. In the shorter vision, we are looking to redefine intralogistics, starting with the big industry of logistics. And our vision is to be able to get any brownfield existing warehouse and turn that warehouse into a fully autonomous, most efficient warehouse on Earth without changing anything physically or without changing any process drastically. So any operation that you can go and see today, once we come in after Atlas, it's going to be fully autonomous, and it's going to be the most efficient, most visible, safest place in the intralogistics. To do that, we are starting from a very tangible but a very large portion of the market. Horizontal pelletized good moves, and our starting point to do that is through an AI-powered, AI-operated autonomous pallet jack.
Oh, cool. Awesome. So first pallet jacks, then the world.
First we take pallet jacks, then we take the world.
Yes, indeed.
So
Yeah.
we can cut that if you want.
No, that's
I think
wonderful.
that was perfect. Maybe a little color on that follow-up. We are actually trying to stay as lean as possible in our product portfolio. We are trying to follow the Pareto principle, if you will. We design very efficient, very capable, ideally multi-purpose, kind of jack of all trades, Swiss Army knife kind of products, so that with one product we can address multiple workflows. So that's one of the reasons why we chose to start with a pallet jack, because if you actually look into the applications of a pallet jack, you see that maybe more than 80% of all intralogistics workflows, like palletized workflows, are actually handled by pallet jacks, including truck loading and unloading, put away, replenishment, outbound staging, etc. So only shelving and unshelving are done by larger forklifts. So that's why we thought that a pallet jack would be a great penetration point, because it covers majority of the use cases and the market. And then we patch the remaining parts up with, again, very cleverly designed additional products. But at the end of the day, we'll be looking at a very, very lean product portfolio that covers all of the use cases that we are interested in.
That's awesome. So, I mean, primarily shipping and logistics right now, and then you're looking at other markets potentially moving forward.
Starting with that, but of course, logistics is such a large industry worldwide, and such a large industry even if you're just looking at the US market. It's trillions and trillions of dollars, and the primary cost is always labor. And it's not just the cost of the labor. just like many other more traditional industries like construction or agriculture, labor, skilled or unskilled, is getting increasingly hard to find, hire, train, and retain. There's always more demanded from those workers. You want to ship more stuff, you want everything to be delivered faster, you don't want to pay for it, etc. And nobody wants to do this job anymore. With that tension creates a lot of extra pressure on the people who are in the field and doing that work today. And that manifests itself in form of overworked people, in form of distracted people, tired people. And that paves the way for a lot of safety-related incidents and accidents. That causes material damage, that causes injuries, and every 3 days someone dies in the United States with a forklift accident.
Oh, wow. I didn't know that.
In about 2 weeks, we actually have a National Forklift Safety Day in the United States. So that's really, really bad. Increasing costs are bad. Being able to deliver more faster and deal with that ever-increasing demand is bad. Something needs to happen. And we think that we are that thing that needs to happen. We are the solution to that.
Awesome. What are you guys doing like differently to some of the other robotic pallet jack companies out there?
Let me take the end point of it. What are we doing in terms of capabilities?
Sure.
Because fundamentally that is the differentiating thing in the marketplace. And then Tekin can talk about behind the scenes, like what are we doing differently from a technical standpoint.
Sounds good.
From a capability point of view, my favorite analogy is that all the existing and previous attempts at warehouse automation, particularly for forklift and pallet jack automation, were like your cruise control in your car. Very narrow, defined task, very limited capability. Sure, there's some value when it works, but it doesn't work in all the environments. It can only complement what you are already doing, which is driving. And sure, it provides some value, but it's not a life-changing addition. We are like the Waymo of this. This is not the cruise control. This is, well, hands off, go into the back seat, sleep there, work, do whatever. You are not needed to pay attention to the road anymore. We are doing that. In other words, instead of just complementing and providing some limited value in a very narrowly defined task, we are going head to head with whatever humans are doing, whatever human operators are making the forklifts do, our machines will do that. It's not just the base case execution of the tasks, like pick up a pallet from here and drop it off there. It's also figuring out when things don't go according to the plan, what went wrong, how to go around that, how to mitigate, and how to react in situ.
Oh, that's pretty cool.
Yeah, maybe diving a little into the technical details. I think my brother kind of made a good overall introduction and alluded to certain parts of it as well. Again, there are some other attempts in the market to automate forklifts and pallet jacks, but at least some of those companies, their approaches are coming more from like a traditional industrial automation direction. But ours, in contrast to that, is more from an autonomous vehicle perspective, because there is this, well, maybe the more traditional industrial automation perspective is kind of viable in certain settings, especially in manufacturing and such, where environments tend to be a bit more structured, actually, with more rigid workflows, because you have to kind of meet certain deadlines, and there are other machines working, and you have to actually fit your work into the allotted slot, right? So, but when it comes to warehousing, unfortunately, those assumptions break. Many people think that warehouses are very, very structured, like super clean, organized, highly efficient kind of places, but unfortunately, that's not the case. A regular warehouse is more like downtown San Francisco. So there is all that chaos, and that's why you cannot just drop like a traditional AGV, and automated guided vehicle, in the middle of like crowded traffic in San Francisco, and and hope that it would actually find its way and be able to operate successfully and optimally and efficiently. So you need actually higher levels of intelligence to deal with all the chaos and all the uncertainty that is brought to the table by all the other agents in the environment. It's not just the moving agents like or the decision-making agents like the other humans, etc. It's also the objects that your robot has to interact with. I usually use that analogy, like whenever a new truck docks to the docking station and you open the gate, it's like Santa's sack. So you don't know what's going to come out. Some of the pellets are really badly populated. Some of them are really badly shrink wrapped. They are broken, etc. So your robot has to be able to smart enough to first detect that and then be able to deal with that. And there is all those additional kind of capabilities that are needed to keep a well streamlined workflow going on, like barcode reading, etc. And all of those capabilities or needs have their own requirements, and you have to be super flexible. You cannot always expect the barcode to be at the exact same location, like pristine conditions, etc. It's going to be wrinkled, it's going to be randomly populated here and there, so your robot has to be able to figure things out that way as well. And whenever you task a robot to do something, like say, okay, take this pallet and bring it to this destination, well, that destination may be available in your warehouse management system in the kind of the ivory tower, if you will, but in reality, maybe that location is occupied. Then what, right? So your robot has to be able to think on its feet and make decisions and make do, like essentially keep the operation going. And in order to be able to do that, you have to implement higher levels of intelligence, and that's why we usually use that autonomous vehicle analogy more than a more traditional industrial automation kind of approach and perspective.
That makes sense. And I can see why you would use the analogy. I mean, having ridden in a Waymo, they're awesome.
Oh, they are awesome. Yeah, so they are making good strides for sure.
Yeah, absolutely. Yeah, I had had a perception at Waymo on here a while ago too. Good friend of mine. Those guys are the best. So you mentioned a few different edge cases, and I'm kind of curious how you handle some of it. So the wrinkled barcode, I mean, I'm a robotics engineer. I imagine like a lot of it's just testing and trying to figure out ways to get it, like different kind of configurations and just case by case. But I mean, you mentioned AI, so I assume you're trying to go toward a general case. What does your approach look like there? And what have you found worked? What are some of the lessons you've learned and kind of things that have ended up on the cutting room floor as you've been working to get there?
Yeah, I mean, of course, I need to be careful about not revealing our kind of secret sources and such, but I can, at a high level, say that we are actually utilizing any kind of advanced technologies and methodologies that is available to us, be that in the machine learning kind of realm or more traditional computer vision planning, kind of symbolic planning kind of realm. That has always been our approach. I mean, we've never been like silver bullet and sledgehammer kind of people, as I mentioned in our previous podcast as well. So I wish it were that simple to have just one thing that actually solves.
I mean, it's idealistic.
That's right. And the real world does not work that way. So that's why we have to bring different components together as a system. And it's a huge toolbox, and you have to have different tools. Again, you have machine learning tools, you have more traditional tools. And when it comes to things like barcode reading, we are utilizing different techniques, like computational photography techniques to essentially...
So effectively, you're like, try this. Did that work? No. Okay, now try this. Okay, did that work? No. Okay, now try this. Oh, yeah, that worked. All right.
And there is like a certain workflow or like a process that you follow when you are doing image processing, for instance. Ideally, you need to have a kind of sharp enough image, right? But whatever image you are receiving may not be sharp enough. So how do you actually make it sharp enough? So there are techniques, some like pre-processing techniques for that. You bring it to a certain stage, and then you kind of filter, crop, and whatnot, find the region of interest in that image, and then do a bunch of additional enhancements, if needed, reconstructions, etc., based on certain like probabilistic models or learned models or whatnot, and then eventually kind of try to decode that that image that you are looking at and identify the barcode or QR code or whatever else you are looking at. So there's all those kind of stages and each sub-stage branches out, and then you try different things, and then again try to bring the region of interest in an as idealistic kind of condition as possible, and then kind of do the final processing on that. So again, without giving like too much detail, all in all, we are utilizing as many different techniques as possible, like whatever is strongest in that particular use case. We are not really married to any particular technique or any particular algorithm. Like whatever does the job best, if that exists in the literature, in the state of the art, we kind of borrow it. If it does not, we invent it. So that's how we operate.
Did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. You can get a hoodie, like the one I'm wearing, t-shirts, hell, we even have whiskey glasses. Everything in the store has custom art that our team worked really, really hard on. So go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code PODCAST10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show. With Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.
Yeah, I mean, you guys were both at the NREC, right? Like at one point, or I mean, I think nobody ever really leaves the NREC. You know, it's like
our hearts
like
are
the Hotel California in that way.
Exactly. You can take the boy out of NREC, but you cannot take NREC out of the boy.
That's awesome.
Yeah, that was definitely a fun phase of our careers. Both myself and my brother spent a few years at NREC at different capacities. We initially started as senior robotics and autonomy engineers, and then switched to the commercialization specialist, special faculty track. And with that kind of hat on, we managed and contributed to different, very high profile, very interesting, very intellectually stimulating projects. Very rewarding as well when you develop a certain technology from scratch, bring it to a certain maturity level and hand it over, and also see it commercialized all the way to the end. That's very satisfying. So we learned a lot from NREC. We kind of ran through that loop multiple times.
Can you say any of the things that came out of that? Or I mean,
yeah, of course. I mean, some of them are things that we cannot perhaps talk in detail about.
Let's talk about those ones.
But some of them are, I mean, they are even on NREC's website. Like, for instance, both myself and my brother, actually he was the lead of that project at some point, worked on the autonomous haulage system with Caterpillar, so those autonomous mining haulage trucks. So I was contributing on the perception end. He was managing the overall project and also doing some work on the machine learning end of it.
When would that have been? Like probably like 2010, like 2012.
The inception of that project.
Inception goes all the way back. I think some CMU Hall of Famers like Chris Urmson, etc., were still around when that project was actually first conceived. Right around we were leaving NREC for Locomation, for starting Locomation. I was the last one to lead the project, and of course I handed over the baton, and I don't know where the state of the art is now, but yeah, like that project easily spanned over 10-15 years.
That's wild.
Yeah.
Now, I remember, I guess the reason I kind of fitted those years was because I was at Joy Global before Komatsu acquired them. That was my first job out of grad school. And I just remember, like, you know, I mean, it's been long enough, I feel like I can say this. Like, my department there was like, you know, like cussing out Caterpillar for having that exclusivity deal with Velodyne that everyone knew about. And so, Yeah, this
Yeah,
is like
they-
over 10 years ago, guys. So
I think if I remember correctly, Velodyne did manufacture a special unit for them.
Right, yeah,
one
it
of those HDL 64 units. It was actually even like a different color, black, right? So, and it had different kind of ratings.
when it was like hardened against like rock
it was
strikes and
hardened.
stuff.
Yeah, it was hardened. Yeah, that was a super fun project. So another very interesting one we worked on was in collaboration with Skorsky. That was a DARPA program called Alias. It was essentially about reducing the number of crew members in an aircraft and implementing some form of like a co-pilot, an intelligent co-pilot system. And it had different phases. In one of the phases, you were supposed to instrument an old aircraft that doesn't even have like a glass cockpit with some computer vision and robotic actuation kind of
What would the
system.
alternative be to a glass cockpit? Like,
Well, it's all like analog devices, essentially, just like hydraulic stuff and all those analog indicators, etc. We literally had cameras looking at a dashboard to like read the speedometer and the attitude indicator to
Oh, interesting.
see the pitch and yaw and roll of the vehicle, etc. So yeah, that was one of the phases, and the other phase was more about learning policies from expert pilots. So like mission specific stuff that you would look at the kind of flight data coming out of those expert pilots' directions and try to associate them with whatever features you could actually identify in the environment and the overall like satellite map or whatnot to extract that policy in kind of like an inverse reinforcement learning slash
Inverse
learning,
optimal
yeah,
control,
inverse
yeah.
optimal control, learning from demonstration kind of paradigm, and then apply it to your autonomous vehicle. And we ended up again working with Skorsky on that, and we had some of our code running on an autonomous helicopter, which was super cool to see. So that was one of the highlights.
One of my personal favorites was a program we did for DARPA. DARPA at some point was very interested in laying the foundation for the next generation vehicles for the Army. And Army has always been interested in completely button-up vehicles, completely armored, so that you don't even have physical line of sight with the outside. So the crew is inside, they are perfectly protected by an armor, and they need to still kind of know what's going on the outside, right? Especially
Ideally.
if you're in like a battlefield, it's like a interesting environment out there. So this program, the part that we undertook was designing a sliding autonomy system that the navigator and the driver can be the same person, and over time you can drive the vehicle from inside without seeing the outside with assistance from autonomy. You could also let go of the steering wheel at a moment's notice, and the vehicle will take over and start driving itself. So you would shift to being a navigator, basically, and you can attend to whatever other urgency that might be in the battlefield. So we developed a very, especially for its time, a very innovative system to replicate that. We didn't have access to the actual military vehicle, but we built a proxy vehicle that you could actually drive from the back seat
oh, cool.
using a completely replicated set of steering wheels, etc.
I'm picturing a Chevy Nova.
It was a Ford F-150 Raptor.
Awesome.
One of the best vehicles I've ever had the privilege to work with. So we did that, and you could sit in the back seat. You would look at a panoramic multi-monitor setup, and you could drive the vehicle just by looking at that. You could do complete manual driving with autonomy assistance, let go of the wheel, and the thing drives itself, and anything in between. The entire engineering, the entire systems design, the entire set of problems that we knew that we were going to face, and we faced and solved, and the problems that we had no idea that we would see, that we found out, and then we were able to overcome, one of the career highlights for sure.
Oh, cool. That's awesome.
A lot of fun.
Yeah, so many good projects. Some of them we got the opportunity to work on together. Some of them, I guess, we did kind of individually. One of the other ones we also worked on together, at least on parts of it, was a Federal Highway Administration sponsored project that we built for like snowplow trucks. So the idea was to build a mapping and localization system, and that would go on a snowplow truck that would be used to map the plowing routes ahead of time before winter hits. And then when winter hits and snow covers everything, you would use the same set of sensors to localize the vehicle against whatever map you built.
Even though it looks totally different now.
Even though it looks totally different, and then on a display in front of the operator, it could be like a see-through display, it could be a regular display. You would actually reflect or display what it would look like if there were no snow. Like, where are the road boundaries? Where are the potentially hidden fire hydrants? Where are the power lines?
Because the mailboxes.
Yeah, because apparently in a rush when the snowplow drivers are doing their job for long hours and such, they can actually knock over things. They can tear power lines if they forget their salt bed.
Compliant snowplows.
Yep. And if the blade angle matches the railroad, like the railroad crossing essentially, then you may tumble the entire vehicle.
Oh, wow.
Right, so yeah, very, very dangerous stuff. Some fatalities as well. So this assistance system would prevent all of those. So that was a super fun project. And some of the stuff that we individually worked on were, like, for instance, I got the opportunity to work on the chimp robot for the DARPA Robotics Challenge.
I did some work for John Deere.
Oh, cool.
Also, so all of these projects are very interesting, very different areas, very different problems. But what that taught us, and some of that was maybe in retrospect, when you look back, every time we go through this roster of projects that we did and what we learned, what we faced, etc., that just taught us over and over again, just like punched us in the face and told us that real world is hard.
Yeah.
Real world is really difficult. Real world is challenging. Just demonstrating something in the real world is hard. Building something that will withstand that brutality of the real world day in and out, weeks, months, years, it's very non-trivial. And there are so many things that you need to understand. It's very counterintuitive, because in the rest of the technical landscape, in academia, you usually are encouraged / funneled to become an expert, an increasingly deeper expert on an increasingly narrow subject. That's kind of the only way to go that far if you want to go that deep. But in the real world, that narrow expertise has some role to play in a project, but never as the overarching expertise. You need to understand the systems. You need to understand how the systems interact with other systems, and how that collection of systems interact and survive the world. That's, I think, maybe the biggest legacy or the biggest takeaway that we brought from NREC with us.
Cool. Yeah, no, I mean, systems engineering certainly is a game changer for making...
Oh, yeah. I mean, it's usually overlooked, but I think it's super crucial.
I mean, you wouldn't be able to make anything complex without it, I think, right? I mean,
Indeed.
That's kind of the thing, is I feel like, you know, if you're just trying to get something done, it's very easy to be like, you know, let's just go on risk and, like, you know, not even do that. But, like, you know, I mean, you would never be able to make something like a space shuttle, or, like, you know, like, I don't know, like most robots, or a car, you know, or like have, you know, more than 10 people working together without, you know, having a set of rules and principles and structure around that work to, you know, tie it all together beyond, you know, like tribal knowledge or intuition of what's right in front of you.
Absolutely. Yeah. I mean, systems engineering is at the core of those kind of complex systems.
Yeah, 100% agree. I am a fan. Systems engineering.
Systems engineering. Kids, do systems engineering.
That's
Yeah.
right.
No, it's the
Br-
coolest engineering.
Brush your teeth and
Brush
then
your teeth
do
and
systems
do
engineering.
systems engineering.
Keep calm and do systems.
That's right.
That is a good T-shirt there. Yeah.
It's I feel like it's as a subdiscipline, it's very it's a challenging one, because I think without context, like I don't understand, how somebody that just went to school for systems engineering could do systems engineering, because I feel like a lot of it, like whenever I meet a systems engineer at work, I feel like they always have some backstory of like, well, I was an electrical engineer and then I got into system, or like I was an aerospace engineer and then, I got into system, or like, I worked in software and now I'm a systems engineer. So I feel like the really good ones have like a background and a context and a career of doing all this different stuff, maybe first without the systems engineering background and then kind of being driven to it, I guess, by necessity.
I mean, when you say systems engineering as a discipline, that's a way of formalizing, capturing, and practicing what it takes to bring together many different components, subsystems, and eventually build this large, complex machine that does a task. It doesn't necessarily have to be that like formal part of the systems engineering. Maybe we can call it systems thinking. When you are, when Tekin said that there are no silver bullets, there are only lead bullets. You just need to use a lot of lead bullets. It's hard. Building systems are hard. You need to understand everything around the system and how they interact with each other. Just having that mentality to know that even if you don't know the details, just know the existence of that. You will have to find out what those individual details are and how they interplay with each other. That, of course, doing it in a formal way is even better, because then it's easier to standardize, easier to document, and easier to hand over to someone else, scale, etc. But that's not just the formal piece. It's the way of life. It's the way of thinking.
All right, so I guess as we end the episode then, is there anything you want to plug on your way out?
High level, of course, it is related to Atlas, and this is the reason why we are very excited, very bullish. I think in our careers of 25 years each in robotics and AI, we've never been this excited and we've never been this bullish about an opportunity. The whole rise of physical AI, which is, I used to roll my eyes on because it's just like a new name for robotics. It's actually not exactly. The type of intelligence that you need to do all the different types of tasks against all the variations of those tasks and under a lot of uncertainty and chaos from the world really requires a very different, very capable type of intelligence. And that intelligence cannot just live in the computers. It needs to be embodied. It needs to be in the physical world, hence the word physical AI. So what we are starting to witness and what we will be witnessing in the next couple of years, 3, 5, 10 years, is going to be based on physical AI. It's going to be a really, I think it's going to probably make more difference in our perceivable day-to-day lives than internet did. We happen to be alive to witness that. We happen to be in a very relevant field, so we are so lucky to be in the right place in the right time and when this rocket ship is going to take off. That also will require a very different way of approaching things, very different way of identifying business opportunities, very different way of crafting solutions for those, and very different ways of building organizations, building the machine that will build the machine. Not completely forgetting everything that was done or was learned before, but really going to a different direction and taking advantage of what is available today that wasn't available yesterday, that wasn't available 6 months ago. That is a very different paradigm. It's a paradigm shift. That's a different way of thinking that. This is coming. And this is going to pave way for a number of different businesses, companies, especially a place like Pittsburgh is wired for this.
Yeah,
That's in this city's DNA. And when you look at other step changes, transformational technologies at least in the last century or so, Pittsburgh found a way of playing a very important role there. So I think that's the plug. Like physical AI is going to change our lives. It's not hypothetical and it's not in the future tense. It already started. We think that we are playing a considerable role there with Atlas. It looks like it's just one industry, one particular application, etc. But it's gonna just like start very slowly and then very fast, and we wouldn't even know like what happened there. So that's the plug. Pay attention to physical AI. Do not just take it as yet another hype or yet another concept that's just gonna come and go. It's a 2 year of excitement and everybody will go back to their corners and keep doing things the way they've been doing things. No. I think the cat is out of the bag. The toothpaste is out of the tube. There's no going back. And of course, with this every new step change like that will bring a lot of good things and a lot of challenges, a lot of potentially harmful things as well. We need to be careful about those, but the goods will outweigh the bad significantly. I think we are in the future. We literally are living in the future, and I invite everybody to pay extra close attention to that going forward. And of course, pay extra attention to Atlas, because you're going to keep hearing that name increasingly more.
Awesome. Well, hey, Çetin, Tekin, pleasure having you guys on. Really appreciate it. Pay attention to Atlas, because you're going to keep hearing that name increasingly more.
Thanks for having us.
Thank you so much, Spencer.
Hey, my pleasure, guys.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause can be found on YouTube, Google Podcasts, Spotify, Apple Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.